Hello, everyone. Welcome to the mid-long-term and systems integrated energy storage session. Today you have the opportunity to talk to Antonio Marco PANTALEO. He is the EIC Program Manager for Energy Systems and Green Technologies. He will introduce you the challenges, so ranging from the scope to the scientific background, also the different categories for the portfolio building, and also its relevance to the European policy agenda. So, for example, the Green Deal that is currently going on in Europe. And we will have a 20 to 30 minutes presentation followed by a Q&A session where you can raise your questions and he will answer. So I hope you all enjoy the session. And Marco, the floor is yours.
Thank you, Juliana. I hope you can hear me properly and you can help me with the slides because I cannot share any slides. So if you can, yes, exactly. Thank you. Share the slide. My name is Antonio Marco PANTALEO, and together with my colleague Francesco Matteucci that presented just a few seconds ago the challenge on CO2 and nitrogen management and valorization, I will introduce now the Pathfinder Challenge on mid and long-term and systems integrated energy storage. Go to the next slide, please. Describing briefly the process to define the challenges, which is generic and applies to all the 6 challenges and to the activities that we carry out with our scientific intelligence work year by year to produce our yearly working program with the EIC. And what is the portfolio approach, what is the rationale behind it, and which is the key novelty introduced with this attempt to reconcile policy and implementation in funding research and innovation in Horizon Europe. Then I will go in detail into the scope of the call and the scientific background, which kind of breakthrough non-incremental research project we are looking for in this challenge, and most importantly, which are the categories that some of the categories that we will adopt to define the portfolio, to build the portfolio project, considering that the Pathfinder Challenge has the ambition from one side to fund breakthrough energy technologies to guarantee a technological leadership of Europe at global level and to explore niche areas and technologies that are worth to be further explored, but not enough funded in other Horizon Europe programs, in particular in Pillar 2, with in the challenges, in particular Challenge 5 on energy and climate and transport, but not only. Also, the other challenges are addressing this kind of topic. And from the other side, has the ambition to build synergies and to facilitate interaction among beneficiaries, among funded projects, retained projects, in order to let the sum to be more than the single component and achieve more ambitious goals with interaction and collaboration among projects which concur to attach the same scientific and technological problem. Let's go to the next slides quickly, and these are just to set the scene of how we define, what are the principles to define the challenges from one side, in particular for the Pathfinder, the non-incremental research opportunities. So the clear, dynamic and vibrating scientific community around promising disruptive research areas that could be very interesting to guarantee European technological autonomy, which from the other side are at their infancy, so not still mature from a technological point of view, with the ambition to produce at the end of the Pathfinder a proof of concept of a technology with a well-defined already in mind application, but testing also at fundamental science level the feasibility of scientific pathways and its potential integration to existing energy systems, as I will describe soon. So non-incremental research is a key for Pathfinder, and also the EU position in the global innovation ecosystem, the presence of excellence research tested and proved by scientific papers, patents, research projects funded at low TRL in this area. We have access to funded and also not funded but inspirational projects in EIC, ERC, and these are all input for us to define key areas, niche market areas where to propose the Pathfinder challenges. Of course, there is always a balance and trade-off with granularity, so be very, very focused on a specific area is to be very selective and less attractive for a broader community. Too broad challenge then has other problems to not be well effective to address a specific scientific topic. And so the trade-off is exactly, as we will see now, to define a key need for the energy system to increase the effort in mid-long-term energy storage, but leaving opportunities to scientists to propose a broad range of technologies options that can be competing or collaborating to attach the broader problem and broader needs of energy transition. Next slide, please. So from the initiation with interaction with experts, scientific experts, with interaction with ERC and studying foresight reports, scientific literature, we go to preliminary set of challenges which are ranging over a quite broad range of options. And so with the brainstorming, we discuss these internally with the other services, and also with structured interviews with key experts, selected experts that have a leading role in the scientific community. And we propose then the final list of challenges approved by member states and before by the services, the European Commission. Next slide, please. And the process here has started at the January, May last year with these informal meetings that I discussed before with experts in not only in scientific sector but also in the business technological sector, also in financial fields, to explore where capitals are going, which trends and technological deep tech areas are mostly funded by venture capitalists, which because we are in a European Innovation Council, so we specifically focus on the application and with the attempt to transfer excellent research into breakthrough innovation, transformational technology that could then be uptaken by the market with solid business model and with a broad range of instruments, funding instruments that we have, in particular the accelerator for startup. So interaction also with manufacturers to understand their needs and their technological challenges that they would like to be addressed. And this was followed by internal discussion with the services, and as I told, and then with discussions with member states in September, October 21st, and then we produced this challenge guide that has been written in the last months and published mid of June, that I invite you to look at. My slides, following slides, are mainly based on the contents of the challenge guide, which is a document which describes more in detail the aim, the purposes of this call, and how we expect to evaluate the proposal, in particular in the second step with a portfolio approach. Next slide, please. So the main challenge is deriving from the needs to decarbonize the energy sector and this fast increasing penetration of intermittent renewable energy, wind, solar mainly, and also the increased need to enable demand response solution at end user levels. So, for instance, the fast increasing penetration of energy communities, smart grids, the need to facilitate sector coupling, and so integration between transport, electricity, gas, heating, water, infrastructures. All this requires a huge effort to increase the flexibility of energy system. How? Facilitating and proposing new technology to enable mid-long-term energy storage. And in these cases, the focus is on electricity and heating. So all technologies that can enable electricity or heat to be stored long-term, using eventually also energy carriers, methanol, ammonia, hydrogen, but with the purpose to enable these mid-long-term storage of these energy vectors, heating, cooling, electricity. We are focusing in particular, or again, also in this challenge, in the use of non-critical raw materials and circularity by design, also in the development of the technology, and we also pay particular attention to potential to integrate the storage technology into broader energy systems. So this technology could be integrated, for instance, into the renewable generation assets themselves. So integration of storage in wind farms, in PVs, or can be integrated in buildings, in greenhouses, in structure, in the built environment. Or these storage technologies could be integrated into into industrial processes, so within industrial symbiosis, and facilitating the interaction among the process systems engineering and the energy storage. Also looking at again the sectors coupling, the possibility to store energy, but also as an added value produce also materials or chemicals. The rationale behind this is clearly the Repower EU, but also 50 of 55 and Green Deal, and the needs to decouple energy systems, facilitate integration of intermittent renewable energy, design products without critical materials, and develop energy storage solution for new market application. We are also thinking to cooling, and so storage for cooling is also well in line with the challenge. Next, please. Here you see where medium long-term energy storage is in the broader set of available technologies. We are excluding short-term storage from seconds to minutes, and we attach the area of energy storage from days to weeks to seasonal storage. So we want capability to store minimum some 100 hours of storage from let's say from 24 hours minimum storage to 100 and above. But we may also explore in the proposal the capability to integrate long-term storage and short-term to enable also the provision of ancillary services to the grid or dynamic response. So this integration is also welcome, but with the key focus on mid-long-term storage. Why these needs? Go to next slide, please. Because there is a clear, the more the higher is next slide, please. The higher is the penetration of wind and PV, the more we need mid-long-term energy storage. Here you can see how daily, weekly, and seasonal storage is more and more needed when we increase the share of electricity from wind and solar on a given national or regional grid. And this avoids curtailments, of course, and enable also better use of existing infrastructure and assets, transmission networks. And there is a clear signals, here you go on the right, you can see slides from Bloomberg, on the fast increasing sector of energy storage. We are funding a lot of startups, companies at higher TRL in energy storage, both electrical and thermal. But here we want to look at less mature and topics more at fundamental science level. Next slide, please. I'll try to speed up. Yes, the scope of the challenge is so to attach the area of thermal, electrical, or combined thermal and electrical energy storage with a duration from days to seasons for stationary applications, not addressing transport, in the mid to large scale size range. So not looking at micro single building solutions, portable devices. We want to fund non-incremental research to produce a proof of concept of a process, technology, or a material, which is however tailored for a specific application or sector already, well clearly defined in the proposal, with the ambition to go from the single component design to the interactions and integration of this component at device and world system level. Technologies are based on mechanical flywheels and only gravimetric on pumped hydro are excluded for the course because we want to focus on thermal, thermomechanical, electrical, electrochemical, chemical storage solutions. When the proposal addressed the possibility to decouple, especially the storage charging, the storage charging from thermal electric energy to energy carrier, and this is charging, so reconversion from energy carrier to thermal electric energy, the focus should be mainly on the storage of the energy carrier. So if you produce hydrogen, storage of hydrogen, or ammonia or methanol, and you can also address sector coupling opportunities, for instance, the combined energy carrier storage and thermal energy management. We can have integration of hydrogen storage with charging this with discharging or accumulation of heat, so there are interaction between thermal energy management and energy carrier. In this case, this is just an example. Technologies that enable increased flexibility and mid-long-term energy storage capabilities of large-scale centralized plants, for instance, refurbishment of all power plants, fossil fuel-based to be energy storage asset, are also relevant interests, but please consider that we are not funding any sort of pilot plants, but low TRL research with proof of concept that could be then interesting and promising also for this application to refurbish power plants and enable energy transition. We can also target the integration of long-term and short-term for storage for fast dynamic response to enable access to energy markets for ancillary services, I told you. Next, please. Some more details on the scope of the challenge. We can attach also secondary benefits of the storage solution, such as cooling management, industrial tertiary sector that could be coupled to the storage of energy, or water management, desalinization combined with storage, carbon capture and management, again, or for instance, culture looping technologies, or technologies that combine environmental remediation or intermediate chemicals production and energy storage. We can address specific technologies specifically designed for renewable heating or electricity storage, so solar thermal integrated with long-term energy storage, geothermal, but also waste heat recovery and seasonal storage. To the extent the primary focus is on storage. And we would like to see in the proposal a clear mention to the deployment strategy, the application, which is already quite well defined, even if we are always talking about low-tier health technologies, so which a number of potential pathways to innovation that can be then explored. Next, please. Range of technologies that we want to explore, not exhaustive list, but just to give some inspiration to understand what we are talking about. Thermal energy storage based on sensible, latent, or thermochemical storage, for instance, absorption process, where we would like to focus on advanced materials, component processes, and system integration levels. Absorption heat storage with by liquid or solid liquid absorption, solid adsorption, reversible chemical reaction, or composite materials, which implies the use of physical or chemical bonds to store thermal energy. Molecule-based storage solutions, for instance, there are trends on photo-switchable or thermally switchable molecules that can accumulate, store energy for long term with reduced energy losses. And this can open fields to thermochemical pumpable fluids, for instance, thermal fuels that can enable long distance heat transmission, for instance, but also the topological optimization of flows and heat transfer surfaces is relevant for this challenge to enable high heat transfer during charging and discharging, such as 3D solutions for heat transfer and by additive manufacturing for pipes and metal foams for surface treatments. Next slide is also including technology for thermomechanical energy storage, power to heat to power, so typically accumulating, consuming electricity to produce heat, maybe mid-high temperature heat, and then produce back this, store this heat, and then produce back electricity when needed by the grid with pumps and compressors that can operate at very high low temperatures and pressure, or at extended temperature ranges where components can be combined, so combining pumps and compressors to reduce cost or increase part load efficiency of this technology. Smart charging and discharging, we realize that there is a limited attention to specifically tailored and designed technologies for these power to heat to power solutions that are very promising, but sometimes we are adapting the technologies, adapting solution technologies to suboptimal implemented in other areas, and we would like to improve here the performance and also reduce cost of these options. In unconventional cycles with vapor compression operated by electrochemical instead of mechanical means, for instance, making use of different forms of entropy changes, such as by redox couples, thermoelectricity, thermoacoustic, or barocaloric materials, are all examples of areas technology that could be interesting for mid-long-term storage, but also chemical energy carriers, for instance, but not exhaustive list, hydrogen, methanol, ammonia, where again we would like to address the storage of energy carrier and handling of the producer's energy carrier that could include the reverse conversion to final use or may not include it, and sector coupling opportunities, for instance, combination to carbon capture and use solutions. And then also focus could be here on the maximization of the overall production, storage utilization, process efficiency, and the assessment of new impurity tolerant, low cost and non-critical raw materials for to enable these chemical energy carriers to penetrate the market. Next slide, please. Focus more on electrochemical storage, and here we are focusing on long duration electrochemical storage, using also exploring the potential integration with thermal storage, so combined thermal electrochemical storage. For instance, reactive metal air batteries or reactive metal as energy storage media such as aluminum, sodium, magnesium. They can have specific advantages in terms of energy density, gravimetric, and can facilitate also interaction with industrial symbiosis with metallurgical industries, or in secondary batteries such as metal air batteries, power to power configuration, or power to metal to power. Redox flow batteries are also relevant in this context, promising because of their long lifetime, low expected low cost, and capability to decouple power and energy, which is particularly also an element particularly important here. We are thinking here in particular to metal organic redox molecules, electrode surface and electrolyte selection, aqueous, non-aqueous reactor optimization, and so on. Next slide, please. Portfolio consideration, we're almost finishing. So portfolio building is based on a balance, a trade-off of complementarities and diversity among the proposals. What does it mean? It means that the evaluation committee will first identify a sufficient broad range of the diverse and competing approach, methodology, and technologies among the portfolio proposals. We don't want to fund all flow batteries or all sorption solutions for thermal energy storage. We want to address a broad range of technologies, and in this range of competing approach, each of them could be promising for a specific market segment, which should be clear. And we want to put to compare these technologies from a broader perspective, trying to use similar metrics that will be a specific activity of the portfolio management, but in combination to the aim to diversify the range of technology and approach. The evaluation commission will also look at complementary shared components among them, so that one project could adopt some solutions and technologies proposed by another project, or there could be synergies and interest to participate to joint workshop and to extend knowledge and to learn from each other and build a community around this funded and retained project. Next slide, please. So the portfolio categories, so to address diversity, how we address diversity, mainly looking at different technologies for thermal, electric, or combination of renewable sources integrated with wind farm or PV, or to existing power plant for refurbishing, or to waste energy recovery, demand response strategies, and these are out of the built environment. These are all examples for us of system integration of storage technology. But also another category is the methodology for materials and component selection. So different approaches of computational chemistry can be adopted to optimize and select the storage materials. This is valid for phase change materials, but also for electrolytes, for flow batteries. And so the thermophysical and chemical, electrochemical properties can be optimized thanks to computational chemistry and with multi-physics simulation. So there is also the dimension of approach methodologies to select and to optimize the materials, and also methodology for monitoring and control, which is another very important dimension. Strategies for charging, discharging systems with a specific dynamic response to control, monitor the durability and the performance of materials, for instance, or components, and to enable fast demand response of these technologies. So combining also the temporal dimension to the dynamic capability. Next slide. I'm probably almost done, probably. Yes, so I sold, as I said, the portfolio should include diverse technologies for thermal and electric storage, comparing the relative competitiveness and market uptake potential. This is, of course, target for the next step during the execution of the projects. Diversity will be also sold with respect to methods for integration of storage into energy systems, as I told, and the aim is to develop a portfolio of potential technology solutions for different application contexts and end user requirements. And the project should, if possible, share similar or complementary approach methodology to select materials, for instance. And in order to, and this will be our specific target to explore during the panel evaluation, to explore potential synergies and identify areas where there is a clear added value for the development of synergies. This will be also taken into account in the definition of project retainer. Other outcomes being equal, preference will be given to proposals which enable increased flexibility of the energy system, high penetration of intermediate renewables, and enhanced demand response strategy, which are the key targets of this challenge. And also, furthermore, potential synergy could be explored in typology of secondary added value. Next slide, please. This is the last one, and I'm almost in half an hour. I'm ready for questions.
Thank you, Marco. I will share the questions now. Thank you. Can you all see?
Yeah.
Can you see my screen? Okay. So the first question is, system integration with direct value for industry is required, which implies a TRL higher than 4, thus exceeding the usual TRLs of a Pathfinder project. Could you clarify?
Yes, it is not required. As I told, this is one potential added value. I explained already that the TRL is low, so it's clear that we are not funding any pilot or no specific activities that imply higher TRL. But having in mind the potential usefulness of a technology to facilitate, for instance, industrial symbiosis, could be an added value. And so some kind of system integration are not at all at low TRL. Are not at all at TRL higher than 4. They could be fundamental research that explore possibility to store energy, combine them with a specific chemical process, and this is not necessarily at TRL higher than 4. Could be also at a fundamental level. And if we are thinking to chemical storage, we can find possibilities also there. The challenge is extremely broad as regards the number of involved storage technology, counting on quite different physical reasons. Is there a clear focus? The focus is on mid-long-term energy storage. We did not want to focus only on electricity storage, only on heating storage. So we address both. So you can store heat for a long term, or you can store electricity, and this is the rationale of the challenge. We, for purpose, keep it broad because we want different technologies to compete and not be very, very focused and sectorial. This has been done for purpose, but there was a negotiation among, as I told, trade-off of very, very detailed focus with the risk to have a limited number of proposals and too broad that will attach probably too many proposals.
Okay, the next one is this challenge will support proposals from the following technologies and systems and gives two options. Should our proposal address both?
No, not necessarily. You can address one or both. So you can address, I repeat, the focus is to produce a proof of concept of the technology, which has the possibility to be system integrated, but the research is not in the system integration at a broader level or at pilot commercial scale level, because we are talking about low TRL.
Okay, the next one. What would be the target system size capacity for decentralized energy storage system solutions?
There is no specific target. We are excluding small scale. So I would say for decentralized energy storage, it is the blocks of buildings, not single building application, but if we can go for blocks of building to higher scale.
Okay. The next question is from Brandon. If our proposal contains 50% TRL 1 to 2 and 50% of TRL 6 to market available, but both are required to prove successful storage, is this acceptable?
Yes, in principle it is, because it's clear that there is an effort to push research at low TRL, also taking advantage from something at more mature technological level. So we understand that with this kind of challenge and with this ambition, we expect that this could be possible, and but also keep in mind that the nature of Pathfinder is always mainly to explore new pathways and not incremental research. But yes, this is could be acceptable.
Okay. Next one. Is the participation of a large multinational energy company in the project considered positively, or the focus is more on SMEs?
There are no strict rules. It can be or not. What is important that each partner has a key role, of course, and contributes clearly to the targets, the achievements of the project, and the proposal is well composed by all the skills, competences needed. So there are no specific rules that corporate is better than small medium enterprise or of the opposite. What is considered for sure positively is to have a clear location of responsibility that are reflected by the background, the knowledge, the leadership of each partner in its specific field.
Okay. If we develop a method for optimizing battery systems and test the method on a pilot scale system, would the inclusion of a pilot scale system be in the scope?
In principle, it cannot be excluded, but it should be clear that the focus is on low TRL technology. So if you can demonstrate and prove that you are able to test it in a pilot scale system, there are no reasons to say that this cannot be done. So in principle, it could be possible to the extent the research has the aim to address breakthrough, not still technological mature technology and innovation.
Okay. The development of new electrochemical energy storage technologies is within the scope of the call?
Yes, it is, to the extent it is addressed to medium-term energy storage, not using critical raw materials. It is.
Okay. The next question is from Maria Elena Diego. Should interaction activities with other projects in the portfolio be considered in the proposal, or this will be added afterwards if the project is funded?
Of course, you cannot know which the other applicants are proposing, so you can we can only add a further work package on portfolio activities, which is what will happen. And some budget will be allocated to this interaction with the other projects, but of course you cannot design your project with in mind that specific collaboration with another project if you don't know it. This is up to us to explore these possibilities. Of course, if you propose something, some fundamental research, very promising that for its nature is very flexible and interesting for other applications, other potential projects, this could be an advantage because it offers you more possibility to be potentially interesting for other research pathways. But of course, any interaction with other projects will be defined when we know the project retained and when we start with the portfolio management, portfolio activities.
Okay, next one. Can hydrogen production and storage system using other renewable energy resources like tidal and wave energy be within the scope of this call?
Yes, it can. Yes.
Okay. My project is in long-term underground energy storage. Is this still in the scope?
Yes.
Okay. How portfolio considerations affect proposal evaluations? For instance, category, monitoring and control affects a proposal, developing new technology or material selection.
No, the purpose of this category is to try to have to cover a broad range of technologies, control systems, system integration. So we can classify project in one or more of these categories, or even in other categories, but it's rather difficult because I don't see how other categories could come, but it could be possible. And with this category, we try to address diversity, to cover a reasonable range of technologies within each category, option in this category, and also look at how the project can work together. I don't know if I understood properly your question. Portfolio consider effect.
I don't know if maybe the person wants to elaborate a bit more in the question.
Category monitor and control affects a proposal developing new technology or material selection.
Material selection. Should we go to the next one and maybe the person? Yes. Okay. Can a project has several breakthroughs to prove as part of a full cycle energy storage project?
Yes, there is no. A project can have more breakthrough. It's a possibility. But I don't know. I don't know at what extent. Of course, a clear focus is welcome, but not necessarily. Maybe several options and several breakthroughs could be also imagined. I don't know.
Okay. Considering that the call covers a broad spectrum of technologies. Oh,
Reviewer expertise.
what happened to the...
It's there.
Considering that the call covers...
Yes. The idea is to have a sufficient expertise to cover the range of scientific domains, areas that are proposed in the challenge, with a particular focus on multidisciplinarities and interaction among different disciplines. Yes, but the ambition is to have to cover all these technology with the reviewer expertise.
The next question, grant negotiations. Do we add WPs, I think work programs, collaboration with other projects before grant agreement or as an amendment?
Usually this is done before the grant agreement, but if you don't put this, which is completely reasonable, in your proposal, we can, on the basis of the potential collaboration with other projects, we can define the tasks and the activities for the portfolio and synergies in the portfolio collaboration. So this can bring to a grant agreement or maybe an amendment later on. But the idea is to have before the grant agreement to add some component in the project to leave a space and budget for collaboration with other projects.
Okay. I would like to ask if testing our novel batteries at a pilot plant would be possible.
Yes, as I told before, is in theoretically not to be excluded, to the extent is clear that the technology has a low TRL, but you can test also in a pilot plant. There is no exclusion. It's not excluded.
Okay. Is it possible for a company valued higher than $1 billion to apply for this program?
You should check the eligibility, but I'm not aware that a corporate cannot be applied. You need to consider you need 3 member states, so the standard rules for eligibility for a Pathfinder Challenge. And you should be a member state and not or associate partner.
Okay.
How many proposals? Well, easy. Depends on the budget asked by each proposal, and we should have about 7-8 proposals to be funded. If we have about 168 billion in 6 calls, which means 20 million in each call, and so about 8 if from 6 to 8 according to the budget asked by each applicant.
Okay.
No, we did not specify a specific metric, which is, for instance, the style of ARPA in their challenges, exactly because we cannot have the same metric for different technologies, markets, application, if we are talking to storage of electricity or, of course, we then want to compare this, but for purpose, as we discussed about very, very low TRL emerging research, it's difficult to put metrics and for something that where we even don't know if the fundamental process works or not. So, but we expect to see some targets of cycle efficiency and expected cost in the proposal.
Can a proposal pass the first step evaluation, but not the second one? For example, the portfolio selection.
Well, of course, yes, because in the which is what happens in the first step. We have last year we received 102 projects. Half of them were with green line, so it means potentially eligible. 55 projects. Of course, we could not fund 55 projects. There was a score that then we adjusted on the basis of portfolio consideration for second step, and we funded the first 7 projects. So 55 projects passed the first step, and only 7 of them were retained for funding. So passing or not passing the first step means that you take you overcome, you exceed the minimum threshold score that is needed. But then not all the projects that have enough high score are funded. Only the highest score, and not the others.
Okay, next one. A technology developed is for other sectors, such as biotech, at TRL4. Is testing its adaptation application in energy storage acceptable? Not being studied yet.
In principle, yes. I have doubts that this TRL4 should be clear that technology needs major research and adjustment to be adapted for the other sector. But yes, this is in line with multidisciplinarities and the idea to adapt from one scientific field to another technology. So in principle, yes.
The next question is regarding the portfolio consideration. Do you rank the proposals independent of categories and then find synergies, or having synergies is part of evaluation?
We rank and then we find synergies. So we allocate each project to a specific, within each category, to specific typology of this category, and then we find synergies. And of course, we start from the highest score projects to check, and the portfolio evaluation has not to do with the quality of the single project, but with the capability of the project to build the interaction with other projects. So in other words, the ranking, the step 1 evaluation is focused only on the proposal, on a specific proposal. Then we allocate proposal to different areas with the ambition to fund project in different areas. So we don't want to fund 2 excellent projects in flow batteries, even if they are maybe the best. But we want to fund the best in flow battery and maybe the second best with a score a bit lower, but still high in molecular thermal storage. And then we explore synergies among projects as well. But the portfolio consideration is mainly to diversify technologies and then to fund projects with shared components.
Okay. Do you have any idea regarding the success rate in this call from the past records?
Yes, 102 proposals submitted in green hydrogen generation, retained for funding 7 or 8, and above threshold about 50. Success rate was about 7%. Yes.
The last question that we have for now, the startup which owns the idea can include advisors on specialized topics such as electrochemistry, or should be the experts on all aspects of the project?
Yes, of course, you can use consultants, in-house consultants or advisor, and outsource part of the work in specific area. This should be clear, yes, that they are part of the team and the work of the team of the consortium, but you can rely on also on external experts somehow. It should be clear, however, which is the added value brought to the project, and how you incorporate these and you define this collaboration among the startup and the expert, on which ground, and but yes, this is expected that if a startup wants to apply, maybe some core knowledge is missing, and this should be taken from key experts. This is reasonable.
To which extent circular economy of proposed technology should be demonstrated?
Well, the boundaries are mainly the technology itself, the proof of concept. We don't want to extend the boundary to the full implementation pilot. Of course, it will be expensive. Will be not the focus of a Pathfinder call it low TRL. Nevertheless, having the idea of the cost benefits of the technology in real environment could be an added package, another contribution to the proposal. But the boundaries of the analysis of the research should be well defined, and in principle, we are expecting that you focus on your specific proof of concept research.
I think these are all questions. I don't know. We still have 4 minutes left. Maybe we can wait 1-2 minutes to see if we find if we get new questions. But maybe, Marco, if you want to wrap up or give some final words and.
Well, final words is mainly on the potential broadness of the area. I understand that is attaching and covering several scientific domains areas, but what we wanted to see also is try to mobilize best scientists and research to apply for this, and try to put in competition some technologies, breakthrough pathways to increase flexibility of energy systems. And we try to exclude some energy storage technologies, exactly to have a bit more focus, such as pumped hydro, gravimetric, mechanical, and we focused on areas that, from what we see and from our background and experience, seem to be among the most promising, and not neglecting the possibility to combine short-term and long-term storage from one side, and thermal and electric storage from the other side, or combining these energy storage with other value benefits. We did not see such challenges in Horizon Europe so far, with these specific focus and targets. So it's clear that we would like to attach an area that's relatively not properly explored, other than in bottom-up calls from ERC, for instance. And that's it.
Here we just have the last question. Is it important to include the entire life cycle of the product in the proposal?
Well, I mean, it should be the product that you are proposing, not something that is already existing where you are applying a life cycle analysis of something relatively standard. Try to focus on the novelty that you are proposing and on life cycle related to the new things that you are adding. Then everything else is not specifically focused or original, probably of the proposal, and could be less relevant, but is general suggestion. So you can focus on the life cycle related to the part that is novel for your technology, proving that your new material that you are adopting has clear benefits against what is before adopted during the wall life cycle of the wall equipment.
Okay, it's 12:30 now, so we have to finalize the session. So thank you everyone for being here. Also thank you, Marco. And yeah, we look forward to having your applications and yeah, hopefully collaborate. So yeah, Marco, you wanna say something?
No, good luck to everybody. I hope to see a lot of excellent proposals and to fund the most that we can, and also to encourage then project excellent and over time to apply to other calls that could be opened in Pillar 2, for instance, in similar areas, which is the case.
Okay. Thank you, everyone. Bye.
Bye.
Thank you.